So the last thing that we're going to discuss is the deflection. This is what we've been shooting for the whole time because this is the item of concern when we're talking about engineering and the engineering design. How much is this beam going to move? Because it's going to be allotted a certain amount, and if it moves over that, it's unacceptable and needs to be redesigned. For an example, if this is 0.1 inch and the calculations come up as 0.15 inch, it's going to be moved too much and you're going to need to redesign it. Okay, so this is the equation for deflection. Deflection is delta. Okay, once again, this is going to be a one-dimensional unit. For our purpose, it's going to be inches. Okay, so delta is always going to be inches. All right, so here's your equation, and lack of better words, you're going to plug and chug. Okay, P is going to be your load, your point load that's specified. Okay, that's always going to be in pounds. Okay, length is the length of the span. Okay, and what I mean by that is that you have two lengths. If this is your roller and your pin, okay, you either have the distance which the supports are, or you have the length of the full beam. Okay, what you'll realize is that the length between the support is going to dictate how much it moves. If we put these really close together, it's not going to move at all. If we spread these a lot apart, it's going to deflect a lot more. So length should be the length of the span. Okay, that's the most important. Once again, that's in inches. E down here is Young's modulus, or modulus of elasticity. Those words are interchanged, okay? Pretty much what they're shooting for on a simplistic basis is the strength. What's the strength of the material you're using? Are you using wood, aluminum? You better believe that's going to change the deflection, okay? Just for some standard numbers here, just ballpark, wood has 2 million psi, aluminum has 10, and steel has 30, okay? I know that doesn't make much, but think about this. Wood, okay, or steel, if you will, is 15 times stronger than wood. That makes about sense, okay? So when we're designing these, the beam's going to be made out of steel, just different beam types, okay, in terms of steel. All right, once again, that's on PSI. And the last thing is I. Well, guess what I is? I is what we've calculated from the beginning, which is our IX, okay? So you're going to calculate the I for your cross-sectional area, then you're going to come back in here, plug this information in to figure out what your deflection is, and then based on that deflection, you'll determine if that's feasible or not for your design, and ultimately that will conclude our beam analysis discussion.